Welcome to Dark Horse Auto and Diesel. Got another non-automotive related video for you today. Should be pretty quick, hopefully. I'm gonna give you a brief rundown on how electric water heaters work and how to diagnose a failed heating element and also how to fix it. Gas water heaters, this is gonna be completely irrelevant. So the way these work, your cold water comes in here and it goes all the way down to the bottom is where the end of this tube is, close to it. Runs all the way down. You've got two heating elements, one down here, one up here, and then your hot water comes back out the top and out to wherever it goes. And the hot water will draw off the top. Like I said, the cold water feeds down at the bottom. And part of the reason for that is just to kind of keep the stuff in the bottom stirred up so you don't get a bunch of crap settling down there. And also, obviously, you want to draw your hot water off the top because heat rises. So under normal operation, your lower heating element is going to be your primary one. The upper one is kind of a backup, more or less. And they will never be used simultaneously. It's either one or the other. And there's switching relays and stuff right here. And so what happens, normal operation, tank's warm, you use a little bit of hot water, the bottom heating element's going to kick on. And the reason the bottom one is the primary is because heat rises. You know, you heat down here, you're heating the entire tank. Whereas if you just heat this one, you're only heating the top part of the tank. You might be wondering now, well, why don't you just always use the bottom? Well, the reason for that is you're taking a long hot shower and you're just using the crap out of your hot water. And let's say you got your washer running too, running hot loads.
Giggity, giggity, giggity.
So what'll happen at that point is you're using hot water faster than what this can heat it. So you're using the crap out of the hot water, cold water's coming in down here at the bottom. That is not going to be able to keep up. But since heat rises, the hot water is still up at the top, it's still drawing off the top. So the bottom will start getting cold. Top's still warm. As the top starts getting cold, there's thermostats in here that'll sense that. And that's when it will switch from the bottom heating element to the top heating element. And that way it's directly heating the water before it comes out. So you're actually heating technically a smaller volume of water at that point in time. And then finish your shower, you turn your laundry off. This is mostly going to be cold water at that point. So your upper heating element is going to be running, heating up this part. Eventually, once it hits a certain point where the top part's hot enough, your bottom is still cold. So it'll switch to the bottom heating element, turn the top one off, and then we'll start heating from the bottom again. By the way, I'm not a professional plumber. I just happen to know a few things and refuse to pay people to do stuff that I'm capable of doing. So hopefully I got that all right, which I'm pretty sure I do. If it's not 100% correct, it's probably 99%. This one has a failed heating element. We'll go over now how to diagnose that. So the situation we had here, you get about 5 minutes of hot water in a shower, and then it's cold. That tells me that the top heating element is working, the bottom one is not. It's only heating the top part of the tank. So you take your shower, you've got, this much hot water in here, and it's empty, so to speak. It's out of hot water. It's just cold water at that point. So obviously the upper heating element is still working, but that tells me that the bottom one probably isn't because it's not heating the whole tank. So first off, before you do any of this, make sure you cut the power, because these are usually 240 volts and that will kill you. If you're not comfortable with electricity, just stop and find somebody that is, hire a plumber. It's not worth killing yourself to save a few bucks. So if you have a little bit of knowledge of electricity and are comfortable working with it, turn your breaker off, and then obviously verify that the voltage is dead. I have not turned the breaker off yet. Good thing I checked. This is why we verify. I thought I'd turned it off, but I didn't. Okay. Now, the power's dead, and we're not. And obviously, you're going to need a multimeter for this to work. So, the easiest way to check your heating elements is put your multimeter on the resistance setting, which is this little horseshoe-looking guy here. That's the symbol for ohms, which is a measurement of electrical resistance. and just ohm out your heating coil. This one's fancy. It beeps at you when it's got continuity. 12.9 ohms. This heating element is good. Now we come down here to the bottom one. 393.4 ohms. And it is not beeping to tell me that it has good continuity. So that tells me this heating element's bad. And the reason that it's actually showing 393.1 ohms, give or take, whatever, is most likely just due to the electrical conductivity in the water. And I'll show you one other little way to verify it as well. Kick the power back on. Turn the faucet on hot. Now I wouldn't do what I'm about to do unless you are very careful. So right now that heating element is not on, but the water's running. And what we can do, all right, so the top of the tank, 120 degrees-ish. Now we'll come down here to the bottom, 73 degrees room temperature. So that right there already tells you that this bottom heating element should be on. And right now, neither one of the heating elements is on. Now it's getting colder already. So I imagine this upper heating element is probably going to be kicking on anytime if it hasn't already. Yep, it's working, but that's why we only get about a few gallons worth of hot water for a shower, and it's cold because, you know, from here up is the only thing that's been heated. So now that we figured out what the problem is, now we just need to look at our tag on here, figure out our model number. In this case, it is the 8V50-2C, and we will get a heating element for it. Figure now is a pretty good time to tell you about heating elements. And for the most part, heating elements are pretty universal. There's just a couple different types that you need to know about. The main one that you need to worry about is how it attaches to your water heater. That I know of, the vast majority of them are the screw-in type, like this here. They do have bolt-on. I think they've got like some clamp-in types, whatever. Just make sure that whatever kind you're getting matches the kind that you have. That's pretty obvious. You want to make sure you match up your wattage, or if you really want, you could actually go lower on the wattage, and it's probably not going to hurt anything. Just don't go higher on the wattage. I've heard of people doing that, and yes, it does heat the water up faster, and you get a little bit more hot water because of it when you're taking a shower, but it's really a bad idea if you aren't 100% certain that all of your wiring can handle it. Because, you know, you could put in a 5500 watt, but you could actually overheat your wiring running to it if it's not the proper gauge. So just, unless you really know what you're doing, get what you already have. Just match it up. And obviously you want to match up your voltage too. They have 120 volt ones. They're not very common that I'm aware of. I think that's just your smaller ones, but most of your big water heaters like this, they're going to use 240. Then the other difference that you need to look at, and it's not overly important, but I'll tell you the difference so you can make the decision for yourself. They're kind of universal with that too. But you can see this one here, it's real long, curves back up. This is what's considered a low density heating element. They also have just regular density or high density. I don't know what they actually call them. These ones are more expensive. This one's also made out of stainless steel. Both will work in pretty much any water heater, but they do have somewhat different applications. So if you've got just city water and it's real clean water, very low mineral content, you can get away with the ones that are just the straight ones, and those are usually like a copper zinc alloy. Somewhat corrosion resistant, but they can still corrode. And then there's, like I said, this type here, the low density, which this one is made out of stainless steel, which is a lot better if you have well water or water with a high mineral content, because being stainless steel, it's obviously going to be more resistant to corrosion. Also, it gives you more surface area that will be less susceptible to just getting completely covered in minerals and stuff. And also the advantage of these low density ones is they tend to have a longer lifespan because they generate the same amount of heat with more surface area. So this actually doesn't get as hot as the other style, which will prolong its life. Now, if you're replacing an upper heating element, this is going to be significantly easier than the bottom one, because next we need to get this thing drained out. Obviously, we got to turn the power off first, turn the water off first. Don't ever have power hooked up to one of these if there's no water covering up the heating element. You can burn the heating element out real quick doing that. Turn the power off. Oops, turned off something else. I don't know what I just turned off. Oh well. And then we'll turn the water off. Now we can drain this thing, and that's what I'm saying. If you're doing the top one, way easier. You've got a lot less water to drain out. You're doing the bottom, lucky me, I've got 60 gallons of water to drain out with a bucket. This is where it's nice if you have a basement, because then you can just dump it out on the floor and nobody cares. Got my draining setup going here, and one thing that's important about doing this is you're going to want to find a way to vent the tank here, and I'm just using the the safety valve here. I've just got it stuck open. Otherwise, you're going to sit here and it's going to create a vacuum, and it's going to take you 3 weeks to drain this thing out. I'll even show you. Close that off. Open my valve up. That's what we get. Open this back up. Releases the vacuum. And there you go. And you could probably also open up hot water faucets in the house, but this is way easier. So I'm going to do this about 30 times and we'll come back. After about the third trip of carrying buckets over to the sink, decided I'm really going to try to find an easier way to do this, and I found this little thing here that's just enough. If I leave this open just a little bit, it'll still drain down in there under the house, obviously for the pressure relief. So I'm just going to let that sit there for a good half hour or so, slowly draining. Probably still be quicker than carrying buckets. Now that you've finally got it drained out, now we'll just unhook the electrical connections from the old heating element. Pretty simple. And then we'll just unscrew this thing. All right, I just used a adjustable wrench here to get this broke loose, rather than try to film me struggling with it. Figured I'd just get it broke loose ahead of time. So once you got it broke loose, you just simply unscrew it. And now you want to just clean up any of this. There's a lot of sediment and crap in here that's pretty freaking nasty. So we'll clean that up a little bit, and then we'll get our new heating element installed. And because of the fact that I don't trust anything anymore, I've had tons of brand new car parts that were junk right out of the box. I'm going to test this before I even waste my time installing it. So got the multimeter back on the ohm setting. There we go. It's good. So now we'll just make sure the O-ring is seated on there properly. And we'll just fish this thing in there. And I'll just run that in snug, off camera. So a little word of advice. A socket definitely works better. I just don't have one available. I'm not a plumber. All of my tools are at my house, and this isn't actually at my house. This is at my mom's house. And be careful when you're doing this, because if you slip, you end up with, bent sheet metal and blood and aids on things. So just a little safety precaution there. This stuff is kind of sharp, and that is way deeper than what it really looks. I'm surprised it's not gushing blood out. Then once you've got it sufficiently snugged up, we can just start getting our wires put back in place here. That's going to take 2 hands, but you get the idea. And I just unclip this from here just so that I had easier access with the wrench. So I'm going to get these wires hooked back up, and then we'll come back. Next, we'll just make sure that all of our, oh, dumbass. Don't do that. Make sure all of our valves are closed before we start unhooking stuff like that. We're going to leave off the covers for right now, just until we can verify that everything works. And we'll turn our feed back on. We'll watch this real quick, make sure it doesn't leak on us. It's going to start building up pressure. I don't have any faucets on yet. And make sure your power is still off right now, because otherwise you will, like I said, burn up the elements. Turn these back on. Don't ask me about this because I can't quite explain it. It has something to do with the hard water here, mineral content and stuff like that. I'm not even going to attempt to explain it because I really can't, because I'm not even 100% sure how this is all supposed to work. I just know that apparently it does. So we'll let this fill up for a minute. Don't forget to close this off too, your pressure relief. All right, we don't appear to have any leaks so far, and I know it's starting to build up a little bit of pressure because I can hear it filling up slower. And you know, right now there's just a whole bunch of air in the system that it's compressing. So what I'm going to go do is open up one of the faucets for the hot water, and we'll wait until we have water coming out of it. Do not let this deceive you. This is just water that was still in the lines. Pretty soon here we're going to see a whole bunch of air coming out, and probably some nasty water as well.
A few moments later.
Yummy. So it's going to do this for possibly several minutes while all the air is getting out of the system, and still have not turned the power on yet to the water heater. We want to make sure that we have a solid stream of, wow, that's getting bad. We have a solid stream of water coming out of here before we even think about turning the power on, because we want to make sure all the air is out of the water heater. And I'm doing this at the sink because it's a lot easier to clean the sink out than a whole shower, and you definitely don't want to use your washing machine to purge the system, because otherwise your clothes are going to just be dirtier than when you started.
You look like you want to get something out, son. My God! I'm bleeding!
Oh, dear God, that's wretched.
Rinse the dirt down with dirty water. So we're going to let this run for several minutes here just to make sure the water heater is completely full of water, and then we will kick the power on and do a little bit more testing just to make sure everything's working properly. Now I let the water run for probably a good 3-4 minutes after the last clip, so go ahead and kick the power on, and now we will wait. Well, actually, we'll verify some stuff here real quick. It's got this weird thing from the power company. I don't know exactly how this works. It's supposed to some kind of, I don't know, load control switch. It ought to kick on any minute here. Yeah, we don't even have power to the unit yet. I think this thing has something to do with energy savings and only using so much power during peak hours and whatever. I don't know. Don't really care. I think she gets some kind of discount on her electricity for having it, so whatever. We'll just wait until this thing kicks on. There we go. Okay, top heating element is getting power. The bottom one is not. I can tell you that already, but I'll show you. Like I said. So this goes back to what I said at the beginning of the video. As of right now, all the water in here is really cold. So once the top part gets heated up enough to where this thermostat registers that, hey, it's warm enough, it'll flip power over to the bottom heating element and then start warming from the bottom. So we'll come back and check this in, I don't know, 15, 20 minutes and see what we're sitting at. Give you an idea where we're at right now. And then at the bottom, we will come back in a few. In the meantime, while I'm waiting for the water heater to heat up, figured I'd play with this a little bit. It appears that I was correct about the water causing, the somewhat resistance reading we had. Once it's out of the water, it's just showing open lead, so it's completely broken. All right, so I just heard this click up here. And what that should mean is that this heating element is no longer getting power, and it is not. And that means that the bottom one should be. Yep. So what had happened is that means that the water up here reached approximately 125 degrees. Not scientifically accurate, obviously. So then it switched power over to the bottom, and we are sitting at 69. Nice. So we'll check back here in a few minutes and see how much warmer it's gotten down here. And as long as everything checks out, as long as it's warming up, then we know the job is successful and we can put the covers back on. I'd say it's definitely working. So now I'm just going to turn the power back off for safety purposes so I don't accidentally touch stuff like that. Get the insulation put back in, get the covers back on, and job well done. If you're anything like me, when you have a job well done, completed successfully, you like to celebrate. So grab the beverage of your choice. And enjoy. If this video helped you, you can actually help this video help other people as well just by hitting the like button down below. That lets the YouTube algorithm know that this was actually a useful video and that it should be shown to more people. Also, consider subscribing. That lets me know personally that you like the content and you'd like to see more of it, and that I'm not just completely wasting my time making these videos.